Friends, welcome back to a new session. So in this video we are discussing about more problems and questions and their solution also based on the previous video sessions. So some questions based on the integration properties, that is integration by successive reduction. So in the previous video we learned that the solution for integral 0 to pi by 2 sin raised to nx dx and integral 0 to pi by 2 cos raised to nx dx also. The solution for these two things are also same. That is, we now for two cases are existing, that is an odd number case and even number case. So these are the two solutions for when n is equal to odd number and n is equal to even number. So in the previous video we discussed the proof with the full derivation of the solution based on integration of 0 to pi by 2 sin raised to nx dx. So if you want to watch that video, so don't worry, the link of the previous video which will be provided in the description box and the end of the video. So before starting this video, don't forget to subscribe our channel for more information updates. So let's begin. So let's check it out some questions and its solution. So first we take an integral 0 to pi by 4 cos raised to 6 2x dx here. So how to find the solution for this integration question? By using the solutions. So let's begin. That is, so the I6, which means that integration of the sixth power of the cos function here. So first we want to note here that here the limit in the question 0 to pi by 2 allowed to use this formula, but here the limit is 0 to pi by 4 is existing. So we want to convert the integration into the 0 to pi by 2 limit, and here 2x is existing. So in this question, note here that here the variable is 2x. So we can use a substitution method here, that is put a t is equal to 2x here, then which mean that find dt divided by dx, that is the derivative of the function, which is equal to 2 into 1 here. Then arrange the equation, then we get the value for dx, which is equal to dt divided by 2 here. Then applies these things in this formula, then we get which is equal to I6, which is equal to, then before writing this formula here we want to convert the limit also, that is, so note here that t is equal to 2x here. So here x have two values, that is 0 and pi by 4, 0 and pi by 4 here. So here we can find corresponding when x is equal to 0, which imply that, note here that when x is equal to 0, 2 into 0 which is equal to 0, that is the value for t, which is equal to 0, t is equal to 0. When x is equal to 0, then t is equal to 0. In the next value, that is pi by 4, that is t is equal to 2 into pi by 4 here, that is 2 into pi by 4. T is equal to 2 into pi by 4, which means that pi by 2. That is when the value for x, which is equal to pi by 4, then which imply that t is equal to pi by 2. So the limit is converted from 0 to pi by 4 to integral 0 to pi by 2. So we get a limit as 0 to pi by 2, then apply here, that is 0 to pi by 2 into cos raised to 6. Cos raised to 6 into 2x, which is converted into t, then put a t here, into dx here, the value for dx which is equal to dt divided by 2, put here dt divided by 2, and here 1 by 2 is a constant, then take it outward, that is 1 by 2 into integral 0 to pi by 2 cos raised to 6t dt. Cos raised to 6t dt here. So from here we can use the integration formula, that is integral 0 to pi by 2 cos raised to nx dx here, that is here 6 is an even number. So we can use the second formula, that is n minus 1 divided by n into n minus 3 divided by n minus 2 into n minus 5 divided by n minus 4 into etc. into 1 by 2 into pi by 2, that is which is equal to 1 by 2 into the n is equal to 6 in value. So we can use 6 minus 1 divided by 6, that is 6 minus 1, which is equal to 5 divided by 6 into the next step n minus 3 divided by n minus 2, that is 6 minus 3, which is equal to 3, and 6 minus 2, which is equal to 4, that is the value is 3 divided by 4. So continuously we get in the next step, that is 6 minus 5, 6 minus 5 divided by 6 minus 4, that is 1 divided by 6 minus 4 is equal to 2 here, into finally when 1 by 2 here existing, then 1 by 2 in the next, after the 1 by 2 there pi by 2 is existing. So we can apply pi by 2 here. Here note that the all numerator have odd numbers and the denominator have the even number. Therefore we can conclude that when applying the equation by n minus 1 and n in the numerator and denominator, that is the first term is n minus 1 in the numerator and n in the denominator, that is when applying the formula and we get 5 divided by 6 here. Then after onward we can apply without the formula, we can find the other values, that is 5 minus 2, then 3 minus 2, etc. That is 5 minus 2 is equal to 3, 3 minus 2 is equal to 1. So like that in the denominator we get 6 minus 2 is equal to 4, 4 minus 2 is equal to 2, etc. Then the final we can conclude that when 1 by 2 is existing, then we can put the pi by 2, and when existing 2 by 3, then we can put the 1 value after in the place of pi by 2 here. So in this formula which is implies these things. So here in the final step we can get a proper solution from here. So let's check it out in another question, that is integral 0 to infinity 1 divided by 1 plus x square whole raised to 4 dx. So here note that we can use the substitution method also and convert the limit 0 to infinity into 0 to pi by 2. So let's check it out. So from the question we can substitute that x is equal to tan t here. So dx divided by dt which is equal to sec square t, that is derivative of tan t which is equal to sec square t. Then here the value for dx which is equal to sec square t into dt. So note here, before writing this equation here we want to convert the limit also, that is 0 and infinity into 0 and pi by 2. But how? Let's check it out. That x have two values here, that is 0 and x is equal to infinity, that is the from the limit x is equal to lower limit is equal to x is equal to 0 and upper limit x is equal to infinity here. Then in the first case, that is when x is equal to 0 here, then we get it as x is equal to 0, that is 0 is equal to tan t. Then we want to check it out that here which value is suitable for the tan function, that is tan t which is equal to sin t divided by cos t. So tan t which is equal to 0 when the numerator is 0. So sin have the value 0 which from sin 0. Then sin 0 divided by cos 0 which is equal to 0 divided by 1. That is equal to 0 into 1 divided by 1 which is equal to 0 also. Therefore the tan t, the value, therefore t is equal to 0 here. So tan get the value 0 when t is equal to 0. That is when x is equal to 0, t is equal to 0 also. In the case infinity, we can check it out that when x is equal to infinity, that is infinity is equal to tan t. Then note here that which is equal to sin t divided by cos t. We want to find the which value have cos function have the 0 in value, that is cos pi by 2. When cos pi by 2 is existing, when this value is equal to 0 there, then sin the cos function have put value as pi by 2, then we get it as 1 divided by 0 here which is equal to infinity. Then note here that the t which is equal to pi by 2 here. Therefore here implies that when x is equal to infinity, then the value for t is equal to pi by 2. So the limit is converted 0 to pi by 2 here. That is integral 0 to pi by 2 1 divided by 1 plus put x is equal to tan square t into whole raised to 4 into dx. The value for dx which is equal to sec square t dt. By using trigonometric identity 1 plus tan square t which is equal to sec square t. That is integral 0 to pi by 2 1 divided by sec square t whole raised to 4 sec square into sec square t dt. Then cancelling these things, then here 2 is existing. Then in the next step which is equal to integral 0 to pi by 2 1 divided by, so in the denominator there exists sec square t whole square, that is sec raised to 4t dt, then which is equal to 0 to pi by 2 cos raised to 4t, that is the reciprocal of sec function which is equal to cos. Then we get like it as, then we can do that. So in the next step we can apply the our formula, that is integral 0 to pi by 2 cos raised to nx dx. Here the value for n which is equal to 4. Therefore the solution which is equal to n divided by 4, that is equal to, sorry, n minus 1. N minus 1 means that 4 minus 1, which is equal to 3 divided by 4 into then minus 2 from the 3, which is equal to 1, and the minus 4 minus 2, then here we get it as 2 into L pi by 2, which is equal to 3 pi divided by 16 here. So friends, let's check it out one more question. So here integral 0 to a x raised to 4 divided by root of a square minus x square dx is existing. So we can use the same substitution method here and convert the limit 0 to a into 0 to pi by 2 here. So first the solution, which imply that x raised to 4 divided by in the denominator root of a square minus x square is existing. So we can use the t is equal to a sin t here. So this is the substitution, sorry, not t, x, that is x is equal to a sin t here. What happened when change the denominator, the x is equal to a sin t here. So let's check dx divided by dt, which is equal to a into d by dx of sin x, that is, or sin t, which is equal to cos t here. Then the value for dx, which is equal to a cos t dt. And note here that we want to convert the limit also 0 to a into 0 to pi by 2. So first here we know that x is equal to a sin t here, x is equal to a sin t. We have the two value for x is equal to 0 and x is equal to a here. So what happened, x is equal to 0, that is x is equal to 0, note here that 0 is equal to a sin t. That is the value for t, which is equal to sin inverse of 0 divided by a, that is sin inverse of 0. Sin inverse of 0, which means that the value which is equal to 0 also, that is the sin 0 which is equal to 0, then the value for the inverse of sin function which is equal to also 0 here. So in the next case, when x is equal to a, which is equal to x is equal to a sin t here, then x is equal to that x value is equal to a here, that is a is equal to a sin t here. So the value for t, which is equal to, here a is existing, and sin inverse of a by a, that is sin inverse of 1. The value for sin function which is equal to 1 when there pi by 2 is existing. So we get limit 0 to pi by 2 from 0 to a here. So in the next step our equation will be converted into integral 0 to pi by 2 into where x raised to 4 is existing, that is the value for x which is equal to a sin t, that is a raised to 4 sin raised to 4t in the numerator, and in the denominator root of a square minus sin square t, root of a square minus a square sin square t into dx, the value for dx which is equal to a cos t, a cos t. So in the denominator we can take an a square outward from the root, then we get it as a raised to 4 in the numerator sin raised to 4t into a cos t. Denominator here a square from the outward of the root when a in the outward, and root of 1 minus sin square t in the inward of the root, and dt. So in the next step, which is equal to 0 to pi by 2, here a and a will be cancelling, and note here that 1 minus sin square t, which will be converted into, so by using the trigonometric identity, 1 minus sin square t which is equal to cos square t, that is the root of cos square t which is equal to square and root will be cancelling, and we get cos t in the denominator, that is a raised to 4 sin raised to 4t divided by cos t here and the cos t here into dt. The cos t will be cancelling, and the final the a raised to 4 which is a constant, that is taken outward, and 0 to pi by 2 sin raised to 4t dt. When solving this equation, then we get it as a raised to 4 into, by using our formula, that is 4 is the power here existing, that is a even number, so we can use it as 3 divided by 4 into and 1 divided by 2 into pi by 2 here. So finally we get the answer as a raised to 4, 3 a raised to 4 pi divided by 16. So this is the final solution here. Let's find out the solution for integral 0 to 1 x raised to 10 divided by root of 1 minus x square dx. So we can use x is equal to substitution, that is sin theta here. And you can use the parameter as theta or t as you like. Then we use here theta. Then dx divided by d theta, which is equal to cos theta here. Then dx is equal to cos theta d theta. So note here that when applying the substitution here, then the limit is also converting. So when x have 0 and 1 value here, what happen when x is equal to 0? That x is equal to sin theta here, x is equal to sin theta here. When x is equal to 0, then what happens? Sin theta, which is equal to 0 also. And when x is equal to 1, that is 1 is equal to sin theta, theta have the value pi by 2 here. Then we get as 2 solution and apply this here, that 0 to pi by 2 limit with x raised to 10, that is sin raised to 10 theta divided by in the denominator root of 1 minus x square, that is 1 minus sin square theta dx, which is equal to cos theta into d theta here, which is equal to integral 0 to pi by 2 sin raised to 10 theta divided by here in the denominator by applying the trigonometric identity, then we get it as cos theta final into cos theta d theta, cos theta cancelling, and we get 0 to pi by 2 sin raised to 10 theta d theta here. Then applying our formula, then we get a proper solution as here 10 numerator 9 divided by 10 into minus 2, 9 minus 2, which is equal to 7 divided by 10 minus 2, which is equal to 8 here into 7 minus 2, which is equal to 5 divided by 6 into 3 divided by 4 into 1 divided by 2 into pi by 2. Find the solution, then we get a proper solution for the integration question as integral 0 to 1 x raised to 10 divided by root of 1 minus x square into dx here. So note here that before winding this session, we will be taken one question for you, that is the DIY for you, that is do it yourself. That is the question is 0 to 3 integral, the integral of 0 to 3 root of x cube divided by 3 minus x dx here. So when you find the solution for this question, you can use the same formula, that is integral 0 to pi by 2 cos raised to nx dx, or it may be sin raised to nx dx. Use that formula, then find the proper solution. And here you can use the substitution as x is equal to 3 sin square theta, and final answer it will be that the outcome become 45 pi divided by 16 here. So please check it out for more improvement. So let's wind up this session and see you soon with a new video. So don't forget to subscribe our channel. So stay tuned with us.